Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you more examples related to proving the trigonometric identities. And we're going to start off with the first question here. Well, when you have an equation as such, you can choose either you want to start on the left-hand side or the right-hand side. So let's say I choose to work from the right-hand side and I need to continue working on it until I reach an answer that matches what you see here on the left-hand side. Okay, so that's what I'm going to do. Now I'm going to consider the right-hand side. So consider right-hand side. So I have sine x, secant of x, and sine x is already in its simple form, so secant of x is can be simplified further. So I'm going to write down sine of x, and secant of x is 1 over cosine of x, and this is just sine of x over cosine of x, and we know that this is the definition, or this is the same as having tangent of x. So there you go. This is quite simple. Now let's look at the second one. Okay, second question. Okay, here I have 1 minus sine squared theta multiplied with tangent squared theta is equal to sine squared theta. So whenever I have this kind of equation, I will always try and choose the complicated side and then work on it until I reach a simple answer which matches the, for example in this one, it will match the right hand side. Okay, so I'm going to choose the left hand side to work on. Alright, so consider the left hand side where we have 1 minus sine squared theta and tangent squared theta. Now 1 minus sine squared theta, according to the trigonometric identity, is just cos squared theta. So cos squared theta, tangent squared theta. Alright, so this one, for this one, I use the identity where you have sine squared theta plus cos squared theta is equal to 1. Therefore, 1 minus sine squared theta will be equal to cos squared theta. Right, next what we can do is we can simplify that some more. I can write down cos squared theta as cos theta times cos theta. Now tangent theta square is equal to tangent theta, and you square it. Now what is tangent theta? So tangent theta is sine theta over cos theta squared. Next, I'm just going to continue on this side. So next I will have cos theta over here. We can expand it, so this is sine theta squared, and at the bottom I have cos theta and cos theta, which of course based on this you can actually cancel these two terms on the top with the ones at the bottom, so you are left with sine theta times sine theta. This is actually sine squared theta. Okay, so there you go. You are able to work on from the left hand side. You work on it until you reach an answer here that matches the right hand side. Alright, I'm going to erase the screen here, and then we are going to look at the last question. Okay, okay, next. So again, I will always choose to work on the complicated side, okay, the more complex side of it. So now I'm going to consider the left hand side, where you have sine theta plus cotangent theta cosine theta. This is what you have, and then this can be simplified as sine theta is already in its simple form. Now cotangent theta is just cotangent theta is 1 over tangent, or it will be cos theta over sine theta. Okay, so that is the definition for cotangent theta times cos theta. So here we have cos theta. So next, what we're going to do next is we're just going to multiply this term over here. So cos theta and cos theta will be cos squared theta over sine theta. And based on this, we can see that we need to add up these two terms. So we need to find the common denominator. In this case, the common denominator is sine theta. Therefore, over here we will have sine theta times sine theta plus cos squared theta. Now sine theta times sine theta will be sine squared theta plus cos squared theta over sine theta. And this one, if you use the trigonometric identity, this will equal to 1. So that will be 1 over sine theta. And this is the definition for cosecant of theta. Okay, all right. Well, thank you for watching. I will see you in the next video with more examples related to proving the trigonometric identities.